Welcome to the webinar Imaris XT, how to write your own Imaris extensions. My name is Sacha Guyer and I'm a software engineer at BitPlane. What will we do today? My main goal is to show you what the value of the Imaris XT interface is and what you can do with it. In a second part, you'll be guided to how to write your own extensions and how to embed it in the Imaris user interface, how to use extensions from other people, and I'll provide you with some details on the extension interface. At the end, I'll give you some hints on what I found is valuable when writing extensions and a list of resources for learning programming XT will be provided at the end. There will be a Q&A session after the talk. Now, what is an extension? An extension is basically a piece of code that you can launch from Imaris that is not part of Imaris. It's written, can be written by anyone external, and it typically gets some data, modifies it, and puts it back into Imaris. Let's have a look at the simple spots example that is delivered with Imaris. If you open a data set and then go to image processing simple spots example, after a few seconds, there will be a spot placed in the center of the image. And if you look at the scene, you'll have the spots component called image center spot. Let's have a look at the source code of this very simple example. So first, it's a Python example. First, we import the Imaris lib, that's the definition of the Imaris XT interface in Python in this case. After the import of Imaris lib, we have one main function, in this case called XT simple spots example, that takes an Imaris ID. Every Imaris application, when started, gets an ID, typically starting from 0. A second instance would get application ID 1. And this ID can be used to identify a specific Imaris instance running. If you launch an extension from Imaris, the ID will automatically be set correctly. So in the first statements after the XT simple spots example definition, we get an instance of the Imaris lib class, and then we can get a handle to Imaris. So v Imaris equals to Imaris lib, get application with the Imaris ID, will return a struct that represents the Imaris application. We place a center spot into the image. So we need to know what is the center position of the image. For that, we get the data set with v image equals to v Imaris.getDataset. This image then has methods to get the extents. So I can do a extend min_x equals image.getExtend min_x. And the same for max. With this, I get the world space position of the image. And if I want to have the center, I just add the two values and divide them by 2. With this, I have the center. I have omitted here some of the other calculations. Then, in order to place the spot, I need to provide a position, a radius, and a time index. And that's what's done here. So v positions equals to, and then it's a list of lists of float. So center x, center y, center c. And then the time indices is 0. I want to place my spot at time index 0. And then the radii is the min radius, which is the minimum of the 3 XYZ sizes. The calculation of this is omitted here. Now that I have the data ready that I want to put into Imaris, I use the factory. I can get the factory from Imaris using the getFactory method. And then I create a spots component. VSpots component equals factory create spots. And then I fill this spots component with data. So there is a method spots component set with 3 parameters, the positions, the time indices, and the radii that are defined above. Then I can do some additional, set some additional values like the name. So I call it image center spot. And then I can also set the color. 255 corresponds to color red. So far, the spots component has been created, but it's not yet added to the scene. So with the last 2 lines, I get a handle to the scene. Scene equals Imaris get surpass scene. And then I add the spots component as a child to the scene. The second argument, the -1, means that it should be added at the end. Now this is, you could say, a stupid example, a very simple example that doesn't really add much value to Imaris, but it still shows the different steps that typically every application, every extension has. So at the beginning, we have a connect where we connect our extension to Imaris. Then we get some data from Imaris. In this case, we get the extents of the image that is currently loaded. Then we process the data. We calculate the center of the image position. And finally, we send back some data to Imaris. In this case, we generate a spots component in the center of the image. And the value of Imaris is now this second step, to process data that is possible in other applications. So you can use Python, you can also use Java or MATLAB to process the data in any way. So this means with Python, where you have lots of libraries, or also with MATLAB or Java, this opens many different possibilities what you can do. And that's the value of Imaris Xt. You can add some functionality that is not there in Imaris. Maybe it's too specific for Imaris and it's not implemented, or it's just missing so far. And you can just use that, put it, process the data, and then put it back. Also, with the embedding of Imaris extension in the Imaris user interface, it's then easy to use extensions from other people. Sharing extensions is quite easy. If you have it as a simple Python script, you can just send that Python script to someone else, or make it available for download on your website. And other people can use it and don't need to understand all the internal things of the extension and still can benefit from it. Imaris Xt has started over 10 years ago and was first using the COM interface and on Windows exclusively. And later it has been changed. We are now using a technology called ICE, Internet Communication Engine. And there are bindings for Java. MATLAB is also using the Java bindings, and there's also Python bindings. We have Python 3.7 support, and we had for a long time Python 2.7. It's still supported, but probably not much used anymore, as it is Python 2.7 is not developed any further. So what exactly can you do with Imaris Xt? Roughly said, you can analyze objects based on their geometry and read, change, and write image data. These are the two big topics, I would say, in Imaris Xt. Raw object geometry and image data. To get into some more detail, you can read and write data for the surpass components, spot surface, filaments, and cells. Then the image, as mentioned. Then you can do tracks, labels. You can use the frame. You can modify the frame object. You can use reference frames, measurement points, clipping planes, the light source, the scene group folders. So as we've seen in the example before, you can add an object to a group, you can generate a group, you can remove objects. Then, in addition to that, you can read statistics values, you can add your own statistics values, you can get and set the labels, you can select objects. So if you have a bunch of spots, you can somehow calculate which spots are interesting and then select them or duplicate them to another spots component and things like that. Then there's also some modifications of the camera. You can take snapshots. These features allow you, for example, to perform your own tracking. If you have your spots detected and you know that the Imaris tracking doesn't work, but you have another tracking algorithm that works better, just get the spots from Imaris, use your own tracking, and then write the tracking results to the spots, and then you can continue working with these tracks in Imaris. Another example and extension that we have is the read super resolution data. There we have super resolution data in basically a TIFF file, a special TIFF file that we don't read. We don't have a proper reader for that, but with the extension, we could load this super resolution data and then generate either spots or generate an image out of this data. There are also some things that Imaris cannot do. So there is no, Imaris Xt cannot do. There is no way to manipulate arena. You cannot do batch processing. All the wizards are not available. Vantage is not available. Animation and colloc is also not available in Xt. And as well, the object appearance. Even though we set the spot to color red in the example before, we don't have the advanced material options available in Xt. And for example, you cannot activate statistics coded coloring for objects. So again, as a rule of thumb, what you can get and set through the Xt interface is the raw data of the geometry of the objects and of the image. Okay, so this was a high-level overview of what you can do with Imaris Xt. I would like to go into some more detail how to write extensions. And we'll do that by walking through, starting from a new Imaris installation to creating a modified version of one of the extensions, and then explain the mechanisms of Imaris Xt. So assume you have Imaris 9.6 installed and you want to write a Python extension. you need to install Python 3.7, the 64-bit version. In my example, I installed it to C Python 3.7_x64. Then you need to specify this Python application in Imaris. So open Imaris Preferences, go to Custom Tools, and this is a screenshot of what you see there. In the bottom part, you can specify the Python 3.7 application. So C Python 3.7 x64 Python Xe. And in the bottom part, extensions folders, there you specify the Xt Python 3 subfolder of the Imaris installation. So C program files bitplane Imaris X64960 Xt Python 3. Imaris comes with 3 sample extensions for Python. When you provide this folder, Imaris will look through the folder and list the objects in the image processing menu. So there are 3 sample applications: Gauss filtering, simple spots example, and surface split. These extensions are not doing, let's say, anything very meaningful, but they help to illustrate what can be done with Imaris XT. So we will run the simple spots example by clicking on it. Well, first load some image and then use the simple spots example menu entry. This will then place a spot in the image, and if you look at the scene, you'll then have there an image center spot, a spots component in the surpass tree. By running that, you know that Imaris XT, running Imaris extensions from Imaris, is working. That's good. So now let's adjust this extension. Create a folder cdata my extensions and copy the Xt simple spots example from the Xt subfolder, Xt Python 3 subfolder, to that new folder. And then open the file in a text editor and change these 2 things. In the beginning, at the comment section, there is an item name simple spots example. Change it to item name my simple spots example. And further below, there in the set name, change it from image center spot to my first spots component. Then open the Imaris Preferences Custom Tools and add this folder cdata my extensions to the extensions folder. If you now go to the image processing menu again, you'll see that there is a new extension called my simple spots example. And you can launch it again, and it will then create another spots component, and this time the name will be my first spots component. This is because we have changed first the embedding of the extension in the Imaris user interface, and second, the name that we give to the spots component. Let me quickly explain how embedding extensions in the Imaris UI works. So apart from the code that you have in your extension, there should be a comment section at the beginning with XML content. And this should look like this. So you have a custom tools, then a menu subfolder, and then item name. The name specifies what will be displayed in the menu item. The tooltip will be shown as tooltip and in the status bar when hovering over the menu item. And then the command tag is important because this defines the language and the entry point. So Python 3 XT tells Imaris use the Python 3 interpreter that was defined in the custom tools and run the method called XT simple spots example. The %i will be replaced by the Imaris application ID when it is launched from the Imaris user interface. If you have a Python 2 extension, the syntax is slightly different. It will be only Python XT in the command tag. And for MATLAB, it's MATLAB XT. And again, the method to enter the extension. It is also possible to place an extension in the Surpass Component Tools tab, and you can also put it into sub-menu entries. I will not go into the details here. If you want to see an example of that, you can, for example, open the XTMATLAB XT spot split into surface objects example. With this, we now understand how to embed an extension in the user interface and how to modify it and how to launch it. What's up next is to see what can we do. So I have described before the different things that we can do with Imaris XT in a high-level manner, but this, of course, maps to different method calls, basically. And I'll show you that in the next slide. To get to the Imaris Xt API, open Imaris and in the Help menu, choose Programming Interface. You will then see the Programming Interface, the welcome page. If you then click on Imaris, you'll see all the classes that are defined inside Imaris XT. If you have a look at this second column here, you see iApplication, iClipping plane, iData container, iData item, many things. Some of them you'll immediately see. iCells is the interface for the cells surpass object, or iSpots, we already have looked at that. There are other classes that are less immediate to understand what they do, but I'll provide you some more samples later. If you then click, for example, on the iSurpass camera, you'll get a list of the methods that this class has. For example, the Surpass camera is the camera in Imaris, so you can set a position, an orientation, and other things. If we now look at the position, we'll see the interface of this method. GetPosition takes no arguments and will return a so-called tFloats, which is on the right side, you see a sequence of floats. Depending on which programming language you use, this sequence will be something different. In case of MATLAB, this sequence is just a vector, and in the case of Python, the sequence is a list of float. You see here an explanation of what the method does, what it returns, and you have a code example. Below this, we see a small Python code snippet that gets the Imaris application and then the camera and returns the position of this camera. So vpos equals camera.getPosition returns a list of 3 float values. To change the position, you could use vCamera setPosition, again with a list of floats, and then the camera in Imaris would be set to a different place. A slightly more sophisticated example or a more complex method for the filament object. A filament is basically a tree structure with 2 different types of nodes. So to define this, you can use, to generate a filament, you can use the iFilaments add filament method. You need to provide positions, radii, types, edges, and a time index. Again, you have a description of what the method does. Add a filament to the surpass component at a specified time point, and a description of the parameters. In this case, for this method, we also have a Python example that you see on the top right. There, the positions, radii, types, and edges are defined, and then filaments add filament is called. This is quite similar to the spots example that we've seen before, with the difference that you have to provide several positions and you also provide the connections between them. The edges define which vertices of the filament should be connected. The types define if they should be dendrite in gray or spine in blue. On the right side, you see the result of calling this sample code. Now, we don't have time to look at all the methods in detail, but I've picked some interesting methods and classes, and I'll quickly show them to you. They should guide you to where to start looking if you want to do specific tasks in Imaris. So, for example, for the image, if you want to get the data of the image, you know, in Imaris you can have huge images, and of course you typically don't want to copy like gigabytes of data in one call. Therefore, the iDataset class has methods to get only a portion of the whole volume. In this example, get data slice bytes, you specify Z slice, a channel, and a time index, and you'll get back a 2D array of the volume voxel data. There are also simpler things to query the data set for, like if you want to know how many channels there are, you can call the iDataset getSizeC method. If you want to do tracking, for example, in the surfaces, you can do an iSurfaces getTrackEdges, and you'll get a sequence of indices that define the tracks between the objects. If you want to set tracks, then you use the setTrackEdges, in this example for the spots component, and again you have to provide edges. It's usually a good idea to use the get method to see what the structure looks like, and then use it in the set method. So you can do a getTrackEdges on a simple data set, maybe with just 2 spots that are tracked, and you'll get back the structure. You can look at it, and then it's easy to find out how to define the structure to then call setTrackEdges. If you want to take a snapshot in Imaris, you can use the I application save snapshot and provide a file name, and an image will be stored to that provided location. Imaris also offers the ability to set labels. Basically, for the Surpass components, you can select individual items and give them a label. A label is basically two strings, a group name and a label name, and you can do that in the Imaris user interface. Using the XT interface, you can get and set it. Therefore, to this end, you use the iDataItem method, the iDataItem class. This is the base class for many Surpass objects. So spots, surfaces, cells, and filaments, they all inherit from iDataItem and have this method getLabels. So yeah, you can do getLabels, then you get this tLabels struct, and you can do a setLabel, where again you provide a tLabel struct. So tLabels is a sequence of CObject label, and CObject label is basically an ID, a label name, and a label group name. If you want to manipulate the folder in the scene, like the root folder of the Imaris scene is a so-called data container, where you can add children or also remove them. For that, you use the add child method. We've already seen that in the simple spots example before. You can also do a get number of children and then iterate through the children to have a look at it. With this, you can just iterate through all the children of the scene to, for example, get all the spots components or all the surface components or whatever is of interest in your extension. The selection allows to select objects in the 3D view. So if you have a spots component with 100 spots, you can in Imaris manually select maybe 20 of them and then use your extension to process them. Sometimes it might be useful to have a semi-automatic extension. That means you perform some of the steps in Imaris manually with the mouse, set the selection of what you find interesting, and then call the extension and process the selected objects. In this example, we use the iCells interface and get the indices of the selected nuclei. In the set example below, we use the iSurfaces interface and select some of the surfaces. Setting the selection using XT results in some of the objects highlighted in yellow in the Imaris 3D view. If you're interested in statistics, you can use the iDataItem. Again, that's the base class for all Surpass objects, and do a get statistics. This will return you a cStatistics values struct, which contains statistics information. That's names, values, and some other things. I don't want to go into detail for that here. You can use also the add statistics method to create new statistics. As an example, we have the extension similarity statistics, where you can select some object and say, I'm interested in, let's say, the sphericity statistics of a surface, and it will then go through all the objects of the surface and compare how the sphericity value of the reference that you set and the other surfaces, how they differ, and return a value between 0 and 1, reporting the similarity of the surface compared to the reference surface that you've selected at the beginning. A special class in the XT interface is the factory. The factory is used, for example, to create a data set. You do this with iFactory create dataset, and you'll get back an iDataset instance. One thing to pay attention to here is that if you create a dataset with the factory, this does not yet set it as the active dataset. It just creates it in memory. If you then want to have this dataset you created displayed in Imaris, you need to use the iApplication set image. I've shown before the set dataset method, and here I show the set image where you specify an image index. For a while, Imaris supports more than one image, so you can load several images at once. And the set dataset is the old method, which just sets the first image. If you want to use several images, then you can specify here with the image index 1, for example, and set the dataset. Then it will create a second image in your Imaris application, and you can then use the frame to move it around. The iImage processing class provides some image processing and also some object detection methods. So as an example here, if you want to Gauss filter your dataset, you can get the dataset from the Imaris application, provide it as an argument here, and specify with sigma smoothing value, and you will get back a dataset. You can then use iApplication set image to set the Gauss filtered dataset. Only when you do that, you will actually see the result. Okay, I don't want to go into more detail here. There are many things to see and to learn in the XT interface, but we don't have time to look into that in more detail. Now let's look at how to use extensions from other people. So basically, if you have an extension from someone else, you maybe got it by email or you download it from the internet, you just place it in one of the folders listed in the extension folders in the custom tools of Imaris that we've seen before. Then it should show up in the Imaris user interface and you can launch it. Now, if you have an extension that uses some Python packages, let's say NumPy, you have to make sure that the Python version you specify in the custom tools actually does have this package. If it doesn't have the package, then the extension will not run. So you need to install it. And one drawback of what we have here is that if you just try to start an extension from Imaris and the package is missing, you will not see the error. Imaris doesn't show compile errors or errors that occur during the execution of extensions. Therefore, I will now go into detail how you launch an extension from a Python IDE. And the main benefit of launching an extension from the Python IDE is that you see errors that you wouldn't see in Imaris. Now, in the next slides, I'll show you how to call a Python extension using Python idle, the integrated development and learning environment. That's a very simple IDE of Python that comes with the Python installation. I choose this one because it's fairly simple to show, but I recommend that you use a more sophisticated Python IDE. Now, if you want to start an extension from the Python IDE, from idle, you first start a Windows command prompt with a cmd exe, and then you launch the Python idle using the script start Python Imaris. I'll explain later what this batch script does, but it's important that you use this one and not just start the idle IDE directly, because then it will not work. So you run command, you have Imaris started. That's also important. You should have an Imaris an Imaris instance running. Then you start the idle, and then you do import my Xt simple spots example. That's loading the module, and then you write my Xt simple spots example, Xt simple spots example 0. 0 would be the Imaris ID, and then this will launch the extension. If everything works fine, it looks like this. So you have the import here in the Python idle IDE in white. You do the import and then the call of the Xt simple spots example method. This is how it looks like in Python. In Imaris, you should see that now this central spot should have appeared. Now, if there is no error, you'll see these 3 arrows, and that indicates that there's no error. If you have some error in the extension, then it will show this error. So here I have just put a raise exception, some exception inside the code of the extension. And just raising an unhandled exception will cause the Imaris script, the Python script to fail. So if you do an my Xt simple spots example, Xt simple spots example, then you'll get this red error message, and you'll see, okay, in line 23 there is an error. There's a raise exception, and that's just the dummy code that I wrote that will generate the exception. If you have another problem like a module not available, then it will tell you here, for example, the NumPy module is not available. Okay, so let's have a look at the start Python Imaris bat file. This is the code of the batch file, and what it basically does, it sets the path here in bold, and it sets the Python path. It needs to set the path because part of the Imaris Python binding, Imaris lib, is using a DLL that is located in the Imaris installation directory. That's why we need to add the Imaris folder to the path variable. With this, it then can load a required DLL. The second thing we have to set is Python path. Python path is a special environment variable that is read by Python, and Python, when it launches, it's looking through all these paths for modules. And it will also have the current folder searched for modules. So this is the start Python Imaris. But at the beginning, there is an Imaris version defined and the Python folder. So this is for Imaris 9.6 with Python installed in C Python 37_x64. If you have a different Imaris version or then you should adjust this batch file. Okay, so if you use this start Python Imaris bat, everything should run fine. Let me show you some example when it doesn't run fine. So here in black at the top, you see if I start idle just normally without the bat file that I've shown you before, and then do an import Imaris lib, it will not find Imaris lib because Imaris lib is located in the Imaris Python, Imaris Xt Python subfolder, and we didn't specify that, so then it's not working. Also, if you specify the path of Imaris wrong, it will not find Imaris lib. Then the second example, if you have Python path correctly, but you didn't set the path, then it will not be able to load Imaris lib, because Imaris lib is using iSpy, which is using a DLL located in the Imaris application directory, and the DLL is not found if it's not added to the path. So these are two examples, two errors that you can see when Imaris is not configured correctly, or the Python is not configured correctly to run Imaris. Good. So let's round up this talk. I'll give you some general advice how to work. I've already given you some advice, and now I'll summarize it here a bit. So if you start writing extensions, start from an existing extension and adjust it. Don't start writing your extension from scratch, and then it will not work, and you will not know why. If you start it and modify it slowly, piece by piece, you see at the beginning it's working, and you change something, it's not working, then you know where the error occurred in the last change that you did. If you start an extension and you have some variable, for example, the v_imaris variable, you can use a simple method like getVersion or setVisible to see if your variable is actually valid or not. Sometimes you get back an invalid variable. For example, if you don't have an Imaris instance loaded, and then calling getVersion will tell you that it cannot call this method. As said before, when you're developing an extension, do it from a Python IDE, don't do it from Imaris. Launching an extension from Imaris is very nice for existing working extensions. But if you're trying to develop an extension, it's much better to start from Python. It's also faster to rerun an application. and an extension. Imagine you have an extension that maybe loads an image, performs some filtering, and you have to enter 3 parameters. Whenever you do this through Imaris, it takes you much longer. It's much better to just hard code these things in the extension and just rerun the extension all the time. Regarding rerunning extensions. So if you start an extension from Imaris, you don't need to reload anything. But if you're in the IDE, in the Python idle IDE, you need to reload the extension before you run it again after you've changed it. I think other IDEs are better there, that you can just run the extension and don't need to manually reload it. And finally, the Imaris Xt API is contains very many and some quite difficult methods with many parameters, and it's sometimes difficult to get all the parameters right. So try to explore a method, try to call it with a minimal example, with just one spot, and if it works with one spot, then try it with 2 spots, so that you slowly get a running and working extension. Especially some argument types, like a list of positions, for example. You could get it wrong. So you can, as I said before, you can use the get method before you use the set method, so that you get an idea of what the structure really looks like. Okay, so my last 2 slides about some resources. How do you get help with writing Imaris extensions? So the main thing, what we've looked at before, is the Imaris programming interface. You access it through Imaris help programming interface. There you see the API with explanations and some sample code for most methods. We have MATLAB examples for most methods and Python examples for some of the methods. On the start page of the Imaris API, you also have some information how you can connect to Imaris from MATLAB and Python. Then in the Imaris Quick Start tutorials, if you go in Imaris to help Quick Start tutorials, fairly at the bottom there is the Imaris Xt tutorial, which is a short introduction to Xt, and it contains MATLAB code where you get a slice of the volume and invert it and write it back to Imaris. There's also explanations about how to embed extensions in the Imaris user interface, what you've seen in this presentation as well. What's also very valuable is to read the source code of the extensions that are shipped with Imaris. So on Windows, in C program files, bitplane Imaris x64960, Xt Python 3, or also Xt MATLAB, there are the sources of roughly 20 extensions. There are 3 Python extensions and 20 MATLAB extensions. So have a look at the code there, and you can see how the Xt interface is used there. On Mac, the location of the extensions is Applications, Imaris 960, App, Contents, Shared Support, Xt, Python 3, or MATLAB. It might also be helpful to just read through the description of the extensions that are shipped with Imaris. With this, you'll get an idea of what is possible. If you go to Imaris help extensions documentation, you'll have a short description of what the extensions do. And if you want to go online, there is the Imaris Learning Center on our website. There are tutorial videos. So if you go to tutorial videos, at the bottom there is customizing Imaris functionality with XT. If you click on that, you'll get about 9 different videos showing an extension and giving some explanation about it. This is more from a user perspective than from a developer's perspective, but useful anyway. If you just search for extension in the Learning Center, you'll find some videos. One, the Imaris Xt introduction, is a video about writing extensions from 2009. It's in MATLAB using the COM interface, which is now outdated, but the interface itself hasn't changed. In this video, you will also see how to generate spots and tracks and how to use the XT interface as reference while developing an extension. So I can recommend that video as well. The Classify Spines extension in Imaris tutorial is one video that shows you how to classify spines into groups. So what the extension does, it's reading all the filament data and then looking at the geometry and grouping it into different groups based on the geometry. Finally, if you have further questions, you can contact the Imaris support team by email or via the web formula in imarisoxins.com/support. This concludes the presentation part of this webinar. Thank you for listening.
Sacha, that was wonderful. Thank you so much. We've gotten a lot of really good questions, and I think the vast majority, if not all of them, have been answered. And so folks, you can see those answers as well. So there's a couple of questions that we want to get to in this Q&A session. So again, thank you, Sacha, for a great presentation. I want to ask you first, can you give us some hints about how you might be able to process multiple images and then read those statistics while using XT?
Yes, sure. Can you hear me fine?
Yes.
Okay, good. So you can, if you have, let's say, 10 images and each image, either you're interested in the image or you're interested in some surpass components that you maybe detected in there, you could just use basically a for loop in an extension and process the data, let's say in a comma separated file format. So you could have here, like I have my image 1 there, I'm interested in surfaces 1. Then I have image 2 there, it's maybe surfaces 12. And then I have image 3 with spots 3, whatever. Then you can start your extension, and read through this file line by line. And then, so for line, and then you have the image name, maybe you have it in the same folder. Then you can just do an iApplication file open where you specify the file name. Then it will open that, and then you can go, then you have it in in the I application get data set. You will get the data set. This is an I data set. Sorry for jumping so quickly through that, but there might be more questions. And then you do, so the I data set is an I data container. An I data item. And there you have get statistics here. So you would do that. And in here, if you have names of the surpass components, you can also get them by doing I application get surpass scene, which is an I data container. So that's a folder. Then you're doing get number of children, get child, you iterate through it, and you do a get name here. And if the name matches this name here, then you know you're at the right data item. And again, you can do a get statistics. So this would be a way to run through several images and process the data in there.
Awesome. Thank you. And it will, all of this is recorded. So even if you went pretty fast, people can go back and forth. So don't worry about that. Okay, so one last question, unless you want to expand on other things on your own. One of our customers here in the States, Neil, was asking about surfaces. They've changed. They changed with version 9.0. So can you expand on that a little bit and talk to us about the new surfaces?
Sure. So with the new surfaces, we have changed the data structure that is below it. So it's no longer just a triangle mesh that you can set and get. The interface has changed and it's a bit more difficult now to do, but it's not, let's say, super difficult. Maybe to generate, if you have a triangle mesh and you want to put that into Imaris, it's more complicated now. But if you want to create a surface, you go to iFactory, create surfaces here. Then you have an iSurfaces, which is just an empty pointer of a surface object, basically. If you then want to actually generate something, you need to use the add surface method. And here in the add surface method, you have to provide an I data item. So this is a data set, basically. And you control the surface to be generated by setting the voxels to something below or above 0. So you have some values here. Below 0 is outside the surface, above 0 is inside. So if you have, now let's try to show that in the application. So basically, if you then set an image, so assume now this here would be maybe -20, and in here you would have 10. Then Imaris would create the surface at where in the 3D space, if you linearly interpolate it, the 0 value would be. So to get started with this, maybe you just create a very simple I data set with maybe only 4x4 pixels, and you set the center pixels to 5 and the outside pixels you set to -5, and you check what's happening to understand that. For direct conversion from triangle meshes to such high data sets. There is no code available, I think, so far. I hope this answers that question. If you have more questions, don't hesitate to write more.
Let's see how quickly they can type though, but everyone should have my email address. So if you have a couple of follow-up questions, we can probably take those through my email, and I'm gonna get a tsunami, but that's okay. Okay, so I think we'll probably wrap it up. We're past the hour now. So thank you again, Sacha. Thank you to everyone that has joined us for all of these homeschool webinars, as well as for all of the members of our team that presented and helped us answering questions, and Rebecca within our marketing team who was here for every single one, making sure we didn't have any disasters with audio or video. So thank you for that. It's been a joy to do this. And we are probably done with homeschools webinars for the near future. I think we will probably pick them back up again in the new year. So stay tuned for new things from us, and everybody take care, and we'll talk to you soon. Thanks again, Sacha.
Thank you. Bye-bye.